All right, let's look at a couple examples. The two main examples that come up with continuously compounding interest. So the first one is I have $2,000, so I have some money that I'm going to put into an account that has 5% interest that is compounded continuously. How much would be in the account after 3 years? So the generic formula for continuous compound interest is A equals P e to the RT. Now, A is the amount that you have after T years. P is what we call the principal. So this is the starting amount, like how much do you start your account with. R is your rate. So just remember, your rate in these equations must always go in as a decimal. And then T is going to be your time, but we always do it in years. So this problem, really, there is nothing to it. We're just really plugging numbers in, because what we want to know is we want to know how much will be left after T years, after 3 years. So we do not know what A is. It is the unknown in this equation. What we do know is we do know P. P is our principal, our starting amount. So that's going to be 2,000. E, now E is that magic number, the base of the natural logarithm. So it's just the number E, and you can find that in your calculator, to the power of R. Now the rate is 0.05. I want to put it as a decimal, times the time, which is 3. Now just be careful. Sometimes you want to make sure you have parentheses around this exponent. So if you believe my calculator, when I just plug this in, because the variable's already by itself, I'm getting $2,323.67 if I round to the nearest cent. So if I put $2,000 in this account, after 3 years, I should have made about $323. So it goes up because I'm making interest continuously. So the whole concept of continuous interest essentially is you're always making interest, but it's a really, really, really small amount. So that's why it's not an infinite amount of money. You're always making interest. It's just a really, really small amount. So that's kind of the easiest problem, where you have money, you put it in, and you want to know how much you have after a certain time. The other kind of problem could be a little more tricky. So this is that tricky problem where, kind of similar, I have $2,000. It's still 5% compounded continuously. But now, instead of knowing the time, I don't know the time. I want to know how long it's going to be until the account has $5,000. So if we think of our A equals P to the RT, in this case, the A we know, because A is how much are we going to have in the future, and in this case, it is $5,000. What we don't know in this case is we don't know what T is. So T is going to be a variable. So $5,000 is what we want to have in the future. We are going to start with 2,000 again. E to the 0.05, but in this case, it's going to be T here. So this is our exponential equation we have to solve. Now the good news is these always solve the same way, and really this is true not only of continuously compounding problems, but in general growth and decay. So I'm going to divide by the number in front. So in this case, that is 2,000. So that is going to yield 5,000 divided by 2,000 is 2.5. I'm just putting that in the calculator. 5,000 divided by 2,000. So 2.5 equals E to the 0.05t. So now there's lots of ways to go. The generic way is to take the logarithm of both sides. So I'll take the log of 2.5, and I'll take the log of E to the 0.05t. Now, it doesn't have to be the natural log. It could be just log. It doesn't honestly matter. So this exponent will go down to the front. So what I have is I have ln 2.5 equals 0.05 t times ln e. The nice thing about using ln e ln of e, since those have the same base and exponent, this is just 1. So that kind of doesn't even play into the problem. So we just get natural log 2.5 equals 0.05t. So if you use natural log instead of common log, the e just kind of goes away. Last step is to divide by 0.05. So t is the natural log of 2.5 divided by 0.05. And I just put that in a calculator. I get 18.3, and that would be years. So when you're trying to solve for time, it takes a little more practice because you have to actually calculate and figure out you have to solve the equation to find your time. Whereas the first kind of problem, you just plug in your numbers and you get your amount. So these are the kind of two problems that you'll kind of encounter. So, if you have other questions, obviously, please let me know. I'd be happy to help you out with those.